What I want to do with this problem is demonstrate probably one of the most powerful algorithms you'll be able to use in many other problems, and that is breadth first search. So you're given a binary matrix of zeros and ones. You can walk on the zeros, you can't walk on the ones, and you want to find the fastest path or shortest path from the top left to the bottom right. I want to edit this input slightly so we can demonstrate how we can find a path from any starting point and any ending point that is the shortest path, and that'll help you to solve many other breadth first search problems as well. So as always, with any grid problem, we want to say mn equals len of grid, and len of grid 0. That's the dimensions of our grid. And now here's where I want to make a small edit. So S0, S1 equals, in this case, your starting point, so 0, 0. And then I want G0 and G1 as the other edit for goal will be n minus 1 and n minus 1. That is the ending point that you want to get to as defined in this problem. But this can be anything. You can start anywhere and you can end anywhere, really. And that's what I want to take away from all of this. And that is, okay, so we have an edge case. So if grid of 0, 0 equals 1, then you can't go anywhere. So return -1. All right. If n is 1 is another edge case. If grid of 0, 0 is 0, you are done. You are done. You have gone from your starting point to your ending point. You landed there right from the beginning. Great. Return 1. Now, in the event that it is n is 1 and you do not have that case, it has not passed, return -1. Now, there is a pretty confusing part to me, at least at first, which was you need a form of iteration for steps, ways to step in the 8 directions that are allowed in the rules conveniently. You need a really convenient way to do this. And the way that's going to be is we're going to have placeholders of directions that we can go by saying 0, 1, 0, -1, and so on. So let me copy and paste this to demonstrate what I mean. So remember, we said there are 8 directions that we want to go: 4, 5, 6, 7, 8. And the way that's going to look is when we add our x, I guess, coordinate, our x piece of our coordinate that we come across as we traverse this grid to our x in our step, right? That means we're moving in the x direction some unit of times. In this case, it's 1 step at a time as we're allowed by the problem, right? And then 1 for y, and then of course there's 0 and -1, right, for y, so to move up and then move down. And then we have our 1, 0, so we'll have, let's say, 1, 0, and then we have -1, let's say -1, 0, and then we have 1, 1, we have 1, 1, and we have 1, -1, let's say, we have -1, -1, and finally we have -1 and 1. Okay, so let's double check this. That's 0, 1, 0, -1, 1, 0, -1, 0, 1, 1, 1, -1, -1, -1, -1, and 1. So that allows us to move in the 8 directions that we are allowed to move in. Now we also need something that keeps track of the coordinates that we've come across, so we don't repeat those. We'll have a set called scene, and we'll add our first coordinate in there, and this is where the real processing actually begins. This is the data structure that really kind of helps us solve this problem elegantly. That is a queue, right? I'll conveniently name it Q for Q, as in a queue, something that is in an order that comes out one way and goes in another. And that is, well, while Q, this is how we'll process it, H equals Q dot pop 0. H equals Q dot pop 0. What that means is we're treating this exactly as a queue. What goes in first will come out first. So first in, first out. Different from a stack. Remember, a stack is first in, last out, much like a stack of plates. A queue, first in, first out. Now, we need placeholders. We need placeholders for the coordinates. AB equals H10 and H11. Okay, so remember, this is h1. This is h1. It'll be your coordinate, right? And we need that as a placeholder because now we're going to traverse through the steps and see how we can move in the directions that we're allowed to move in, and if they pass as well. Also, remember, we need a way to tell the program, hey, stop processing if we've gotten to the end and we are good to go. So if a equals g0 and b equals g1 and grid of g0, g1 equals 0, return h0. Okay, what are we doing here? We're saying if you've gotten to the goal where a is g0 and b is g1, and that goal is a 0 in that cell, meaning we can walk on it, we have gotten our shortest path. This is a breadth first search. The reason we can return this without doing any more processing is that in a breadth first search in this manner, by the time we get to the goal, we've gotten to at least the shortest route. Now there are other routes that may be as short, but none that will be shorter, right? At best, the shortest route is here. Now, let's go back to Q for a second. What's happening? When we pop off of Q, we have 1 in here. That 1 is what we're using to keep track of the length of our path, right? So at 0, we have a length of path of 1, and then we'll need to increment that as we traverse through our grid. Okay, so now that we've seen this, now that we've seen this coordinate, we need to add it. We need to add it to our scene set, and that scene set is going to be scene.add our coordinate, h1. Now for essence steps. For essence steps, we want to say CD equals A plus S0, B plus S1. This is what I was talking about earlier, the 8 steps that the 8 directions rather, that we're allowed to move from the prompt, which are the left, down, up, right, and then the diagonals as well. So CD equals A, where we're at, that's the coordinate we're at, plus the steps and the directions that we're allowed to go. So if let's say, rather, if CD in scene or not C 0 is less than or equal to C is less than N, and 0 is less than or equal to D is less than N, or grid CD is 1, we don't want to process anything. Continue. That means that this coordinate has been seen before because it's in scene, right? We've seen it before. Or it's outside the bounds, which is that C, our xth coordinate, is not inside of 0 and the bound of our grid, and 0 is less than or equal to D is less than N, where D is not in the bound of our grid either. Or grid CD is 1, we can't even walk there. Continue. There's no processing left to do. There's no processing left to do. So what we want to do after that is, in the event that we have that this passes and we don't need to continue, and that continue, keep in mind, in Python means do not do any more processing in this loop, move on to the next iteration. Scene.add C, D, that is the coordinate that we're looking at. Okay, then Q.append, and we have H0 plus 1 because we're taking a step in some direction, and then C, D, and we have our appending. Great. Now, in the event that none of this results in reaching the end, we want to return -1 as is required in the directions on the left. We run this and accepted, submit, outstanding.